Imagine this, you're an astronaut millions of miles from Earth enjoying a cup of coffee inside your spacecraft. Suddenly, you hit a bump, and your precious beverage goes flying. In zero gravity, coffee forms floating globules instead of a puddle. This behavior highlights the challenges of living and working in space. Spilled coffee can pose unique risks in a spacecraft. Next time you sip your coffee, think of the astronauts aboard the ISS. On Earth, we're used to liquids behaving in a predictable way. They flow downward due to gravity, forming puddles or streams. However, in the microgravity environment of space, gravity's pull is significantly weaker. This lack of a strong gravitational force has a profound effect on how liquids behave. Without gravity to pull them down, liquids in space are free to move in all directions. They tend to assume a spherical shape due to surface tension, a force that causes the molecules on the surface of a liquid to stick together. This is why spilled coffee forms into globules rather than spreading out on a surface. The behavior of liquids in microgravity presents unique challenges for astronauts. Simple tasks like drinking, washing, and conducting experiments require special equipment and procedures. Understanding how liquids behave in space is crucial for designing spacecraft systems, conducting scientific experiments, and ensuring the safety and well-being of astronauts. Imagine coffee suspended in midair, forming perfect spheres that shimmer like miniature planets. This is the captivating sight of coffee globules in space. These mesmerizing formations are a testament to the power of surface tension, a force that dominates liquid behavior in microgravity. Surface tension arises from the cohesive forces between liquid molecules. These forces pull the molecules together, minimizing the surface area of the liquid. In the absence of gravity, surface tension becomes the dominant force, shaping liquids into spheres, the geometry with the least surface area for a given volume. The size of a coffee globule depends on the amount of coffee spilled and the forces acting upon it. A gentle nudge can send a globule drifting across the cabin, while a collision with another globule can cause them to merge into a larger sphere. These floating spheres of coffee, while visually intriguing, are a constant reminder of the challenges of containing and managing liquids in space. Cleaning up a spill on Earth is simple. A quick wipe with a paper towel usually does the trick. In microgravity, cleaning spills is much more complicated. Spilled coffee remains suspended, posing a hazard to crew and equipment. Astronauts use specialized tools and techniques to clean up spills. Absorbent towels or sponges collect floating liquid. A vacuum device can also be used to suction up the liquid. Cleaning spills in space prevents equipment damage and ensures crew safety. Section 5. The threat to equipment, corrosion, and short circuits. While a floating globule of coffee might seem harmless, it can pose a serious threat to the sophisticated equipment inside a spacecraft. The delicate electronics and intricate systems that keep a spacecraft operational are highly susceptible to damage from liquids. Coffee, like many other liquids, is corrosive. If left unattended, it can damage sensitive components, leading to malfunctions or even system failures. The intricate wiring and circuitry inside electronic equipment are particularly vulnerable to short circuits caused by liquid intrusion. In the confined and controlled environment of a spacecraft, even a small amount of liquid in the wrong place can have catastrophic consequences. A short circuit in a critical system could jeopardize the mission, or even put the crew's lives at risk. Section 6. Filtration systems. Clogging the lifelines of spacecraft. Spacecraft rely on complex filtration systems to maintain a clean and breathable atmosphere for the crew. These systems work tirelessly to remove dust, debris, and other contaminants from the air, ensuring a safe and healthy living environment. However, spills can pose a significant challenge to these vital systems. Liquids, especially those containing sugars or other sticky substances like coffee, can clog the filters, reducing their efficiency or even causing them to fail. A clogged filter can lead to a buildup of harmful contaminants in the air, posing a health risk to the astronauts. Moreover, replacing or repairing filtration systems in space is a complex and time-consuming process. Astronauts must dedicate valuable time and resources to address these issues, diverting them from their primary mission objectives. Section 7. Microbial growth, an uninvited guest in your coffee. In the closed environment of a spacecraft where air and water are carefully recycled, microbial growth is a constant concern. Spilled liquids, especially those containing sugars like coffee, can provide an ideal breeding ground for bacteria and fungi. Microbes thrive in warm, moist environments. A spilled cup of coffee, even after it dries, can leave behind residues that provide the necessary nutrients and moisture for microbial growth. These microbes can then become airborne, potentially contaminating other surfaces and posing a health risk to the crew. Astronauts have a weakened immune system in space, making them more susceptible to infections. Even a seemingly harmless microbial growth could lead to health complications during long-duration space missions. Section 8. The importance of spill prevention and containment. Given the potential risks and challenges associated with spills in space, preventing them from happening in the first place is paramount. Spacecraft designers and engineers go to great lengths to develop systems and procedures that minimize the likelihood of spills. Cups and containers used in space are specially designed with features like lids, straws, and surface tension screens to prevent liquids from escaping. Astronauts undergo rigorous training to learn how to handle liquids safely in microgravity, practicing techniques that minimize sloshing and splashing. Despite these precautions, spills can still happen. That's why spacecraft are also equipped with containment systems, such as absorbent materials and vacuum devices, to quickly and efficiently clean up any spills that do occur. Section 9. Future Solutions, Innovations for a Cleaner Space Environment. As we venture further into space and embark on longer missions, finding innovative solutions to manage liquids and prevent spills becomes increasingly critical. Researchers and engineers are constantly exploring new technologies and materials to address these challenges. One promising area of research is the development of superhydrophobic surfaces. These surfaces repel liquids, causing them to bead up and roll off, making it much more difficult for spills to occur. Imagine a spacecraft interior where liquids simply bounce off surfaces, leaving no trace behind. Another area of innovation is the development of self-cleaning materials that can break down and neutralize spilled liquids, preventing microbial growth and corrosion. These materials could revolutionize spacecraft design, creating a cleaner and safer environment for astronauts. Section 10. Conclusion, a universe of challenges and discoveries. Spilling coffee in space might seem like a trivial matter, but it highlights the unique challenges and wonders of living and working in microgravity. It underscores the importance of understanding the behavior of liquids in space, the need for robust spill prevention and containment systems, and the constant quest for innovative solutions. As we continue to explore the cosmos, learning how to manage and adapt to the challenges of space will be crucial to the success of our missions. Each spilled cup of coffee, each floating globule is a reminder of the ingenuity and resilience required to push the boundaries of human exploration.